First, you want to orient yourself with the heart. So what I do is I look for the little peak, okay? The point right here. This is the apex of the heart. This is the base of the heart. The base is where all the vessels come off. The apex is where it comes to a point, all right? How do you tell anterior from posterior? Anterior, you'll see this little thing that looks like a flap or a little wing. This is called an auricle. And then you see this large blood vessel that is kind of slanted, little diagonal. This is the pulmonary trunk. When you see an auricle and the pulmonary trunk, this is the anterior side of the heart. If you turn it around, it doesn't look the same. No pulmonary trunk, no auricle. See, this isn't it's not a flap, okay? It doesn't look like a little wing, right? So this is the posterior side of the heart, right? Now tissues. All right, so on the back, you can see this kind of flap of stuff, okay? This is called the pericardial sac, or what's left of it at least. So this pericardial sac is a tough, dense connective tissue, and it just plays protective roles. So it just protects the heart. So at one point, this pericardial sac actually encapsulated the entire heart, but we had to cut it away so that you could see the heart, okay? So this is what's left of the pericardial sac. When you're touching the heart, just touching the outside of the heart, anywhere, what you're touching is the tissue called epicardium. Epicardium because epi means above, okay? So it's what's directly attached to the outside of the heart. It's also called the visceral pericardium. If you remember learning the serous membranes, the visceral is actually attached to the organ, whereas the parietal lines the cavity. Does anyone remember that? So epicardium and visceral pericardium means the same thing, okay? All right, when you open the heart, okay, what you'll notice is these cavities, these spaces. Those are either going to be atria or ventricles. I'll tell you how to identify them. Lining those, do you see the tissue? It's really smooth. That really smooth tissue that lines the cavities, it's called endocardium. Endo because it's the most inside, and it's really, really smooth because this is where blood is going to touch. Blood is going to flow through these cavities. We don't want blood to have a lot of friction against it. We want it to flow very nicely and quickly, so we want that tissue to be really smooth, right? The tissue that surrounds the cavities, all of this really thick stuff, this is all myocardium. Myo meaning what? Muscle, okay? So this is the tissue that is actually going to contract, okay? So myocardium. How do you know, like on the test, am I asking ventricle? Am I asking the tissue type? Like what is it that I'm asking from the heart, right? So you'll know what I'm asking because I'll have a note card right next to each station, and the note card will have questions on it that go along with the numbers. So if I have a pin in here, I'll have a note card next to it and say, what is this specific type of tissue? You would say myocardium. What is this tissue called? Myocardium, okay? This is also called the interventricular septum because inter meaning between, ventricular because it's in between the two ventricles. So this is also called the interventricular septum. So if I ask, what is this specific structure, you would say interventricular septum. If I say, what is this specific type of tissue, you would say myocardium. Does that make sense? Okay, so I'll have a note card with a question next to it that lets you know what is it that I'm looking for. This interventricular septum, this is going to be where those Purkinje fibers that come down from the AV bundle are going to run down this interventricular septum until they eventually curve upward and innervate the ventricles. So that's where they travel down, okay? Right? So this is where you'd find the Purkinje fibers, and then they would come up and, you know, wrap upwards and innervate the ventricles, causing the contractions. All right? On the front of the heart, so here's the anterior part of the heart, this right here, you can kind of see what looks like a groove. This is called the interventricular groove, right? It's just a way to help orient yourself. Interventricular groove, you can see that it kind of goes along with the interventricular septum, right? So left is going to be on this side, right is going to be on this side. And I know left and right because left, really big. Do you see the size discrepancy? This is huge, this is small. This is left, this is right, okay? And I know that because the left side deals with pumping oxygenated blood to the entire body. So from your heart to your tippy toes and your fingertips, it's a really far away. So you need lots of force behind it, which means you need lots of muscle contraction behind it. So the left side is really, really thick. The right side, where is it going? Does anyone know where the right side goes? To the lungs. So the right side of the heart deals with getting deoxygenated blood to the lungs to get reoxygenated. Where are the lungs located?
Beside the heart.
Lateral to the heart, right? So the lungs are located lateral to the heart, really close to it, right? So you don't need lots of force. You don't need lots of pressure behind the blood going to the lungs because the lungs are right there. So it makes sense that this side of the heart, the right side, is much thinner, much smaller than the left side because of where it's going. Does that make sense? Okay, so now we're going to start going through the systemic circulation, and I'll point out structures as we go. I like to start off at the lungs. So we're at the lungs. What happens at the lungs? Gas exchange. O2 in, CO2 out, right? So now we have this blood that is freshly oxygenated, and where do we need to get it? To the heart. Why? So the heart can pump it to the body. Fantastic. Okay, so we go from the lungs through what we call pulmonary veins. You don't have to identify pulmonary veins on this because they've been cut away. Like right here, there would be a few pulmonary veins on this side because this is the left side of the heart. I don't know if you can, I don't have it on the list, but you should know it in the flow of systemic blood, but I don't think you can identify it on any of the models. So from the lungs through pulmonary veins, this is an example of veins having oxygenated blood, because the best definition of a vein is it carries blood to the heart. Arteries carry blood away from the heart. So the pulmonary veins are carrying blood to the heart, but it's oxygenated, right? So through pulmonary veins into the left atrium, all the way up here towards the base of the heart, okay? Into the left atrium, okay? The left atria, it's going to contract. It's going to push blood down into the ventricles. So think V, ventricle. All right? So here's the ventricle, here's the atria. How do I know where the atria ends and the ventricle begins? It's because you look for these flap. This is a valve, okay? What's the point of a valve? A valve is going to prevent backflow of the blood. It's going to make sure there's a unidirectional flow of blood. Unidirectional meaning one way only, right? It makes sense. We want blood to go one way. We want it to get up and out to the tissues. We don't want it to pool in the heart, right? So this, because it's on the left side, this valve is called the bicuspid or the mitral valve. Either name works. These valves, these flaps, need to be anchored, right? So that the valve doesn't flap back up into the atria. That's called a prolapse valve. We don't want that to happen. So here, these strings, these are called chordae tendineae. Those are the things that are going to anchor the valve down and anchor it to a papillary muscle. So where the chordae tendineae anchor into the endocardium, that's called a papillary muscle. Think of a tent, right? Here, this is the tent itself. Then you have these strings that kind of hold the tent, and then the stakes, which are the papillary muscles that actually anchor it into the ground, okay? And this is, again, to prevent backflow. It only goes one way, right? And that way is from the atria down into the ventricles. Ventricles contract. It's going to push blood up and out. So remember the contractions start towards the apex and then go up through the ventricles. So the blood is going to be pushed up and out through the aortic semilunar valve. You can't see it on the cow heart, but you can see it on the model, okay? Through the aortic semilunar valve, does the same thing as the other valves in the heart. It's going to make sure it goes one direction only, prevents backflow. Through the aortic semilunar valve, through the aorta, this large vessel coming directly off the top of the heart, this is going to be the aorta, all right? From the aorta, through arteries, then through arterioles, and then to capillaries, okay? The only difference between an artery and an arteriole is going to be the amount of smooth muscle and its diameter, okay? Arteries have a larger diameter. Arterioles, oles means small or little, so it has a smaller diameter. And then capillaries, pretty much, they're large enough just to let a red blood cell by, right? So if you can only go single file through capillaries, does that mean it's going to be real fast or real slow? Slow. Why do we want the blood to kind of stop and go really slowly through the capillaries? What happens at the capillaries?
Yeah, we got nutrient exchange or
Nutrient exchange. So at the capillaries, oxygen will diffuse into the tissues, CO2 will go from the tissues into the blood, right? So in order to have optimal diffusion of gases and nutrients and waste products, we need to kind of slow down the blood. But in order to slow down the blood, we can't just like abruptly slow it down at the capillaries. So we get smaller. We go from arteries to arterioles to capillaries. And in the process, we're slowing down the blood. Okay, so that it goes slower through the capillaries. We have optimal gas exchange. Now we have blood that is deoxygenated, rich in CO2, low in O2. It's going to travel, it needs to go where? So we have deoxygenated blood. Where does it need to go? To the lungs. But how do we get it back to the lungs? It's lost all its pressure. It's so slow now. We got to get it back to the heart, and then the heart will pump it to the lungs, and then the lungs will reoxygenate it, right? So from the capillaries, we're going to go through venules, and then veins, and then back to the heart, okay? If it's deoxygenated blood coming from below the heart, it's going to enter in through the inferior vena cava. If it's deoxygenated blood from above the heart, it's going to enter the heart through the superior vena cava. And if it's deoxygenated blood from the heart itself, it's going to enter through the coronary sinus, okay? So to see those structures, we have to look at the posterior side of the heart, okay? So here, left side, so think still left side, this vessel right here, kind of right next to the base of the heart where all the vessels come off of. Okay, this is the inferior vena cava where all the deoxygenated blood from below the heart's going to go. Up here, okay, more superiorly, this is the superior vena cava where all the deoxygenated blood from above the heart will go. And when you put your gloves on and you look at the heart, you'll be able to tell your fingers are touching. So it's all going to the same place. My fingers are touching right now. This area right here, right next to the superior and inferior vena cava, is the coronary sinus. The coronary sinus is going to have all of the deoxygenated blood from the blood that actually supplied the heart, okay? So coronary sinus, superior vena cava, inferior vena cava, all lead into the what? Right atrium, okay? So actually on this heart, the right atrium is like all the way up in here. You can't really see it, but you can definitely see the right atrium on the models and maybe the other cow hearts, okay? But a good way to tell atria and ventricles, again, ventricles have a V shape to them, and you're gonna see the flaps, and then whatever is above the flap is gonna be the atria, right? So in through the inferior superior vena cava, coronary sinus, into the right atrium, the atria will contract. The blood is going to go through the tricuspid valve, which y'all see it deep in there. The tricuspid valve with the chordae tendineae. Tricuspid valve deep in here with the chordae tendineae and the papillary muscles. Okay, so through the tricuspid valve, tri because there's three, okay, and it's on the right side, into the right ventricle, which is right here. The ventricles contract. The blood is going to go up and out through the pulmonary semilunar valve, which you can't see on here, but you can see on the models, through the pulmonary semilunar valve, through the pulmonary trunk, right? Here's the pulmonary trunk right here. This is that large vessel on the anterior part of the heart that's kind of slanted or at a diagonal. Pulmonary trunk. This is an example of an artery that's deoxygenated, right? So this pulmonary trunk, you'll also hear it referred to as the pulmonary artery, okay? It's coming from the right ventricle, which has deoxygenated blood, and it's going to the lungs, so it's leaving the heart, so it's an artery, but it has deoxygenated blood, right? Okay, so from the pulmonary trunk to the lungs. What happens at the lungs? Gas exchange. O2 in, CO2 out, and then we start all the way back over, going through the pulmonary veins to the left atria, blah, 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 okay? These things are happening simultaneously. When you're first learning about the heart, it's easier to learn it by compartmentalizing it, like the left side, the right side, the entire flow, but you have to realize that the left and right atria are contracting at the same time. The left and right ventricles are contracting at the same time. The same time blood is being pumped to your body, blood is being pumped to your lungs. It's all simultaneous, okay? But splitting it up just makes it easier to learn at the beginning. Yeah?
Yeah.
Whew, okay.